Hello, this is Walker Physics, Chapter 7 on Work and Kinetic Energy, and this is number 33 from the end of the chapter questions. A 1.2 kilogram block is held against a spring of force constant 1 times 10 to the 4th newtons per meter, compressing it a distance of 0.15 meters. How fast is the block moving after it's released and the spring pushes it away? All right. I want to know if you know what to do. You've got two formulas. You've got a spring formula. Remember Hooke's law. And Hooke's law is work equals 1/2. K is the constant of the spring. It's how stiff that spring is, times x squared, which is the distance. Right? You also have work equals force times distance, if you need that, and you have work equals 1/2 mv squared. So here's the spring constant. We're going to use that, and then we're going to use this because it has a velocity, right? And the work will be the same. The work that was done in order to compress the spring stored energy in the spring. Now that energy is free to push the block away at a certain speed. Okay, it's like energy in, energy out. Okay, so let's find out. So let's find out first of all the spring. We have work equals 1/2. The constant was 1 times 10 to the 4th, and the distance was 0.15 squared. Okay, and so 1 times 10 to the 4th times 0.15 equals times 0.15 equals divided by 2 equals 112.5 joules. Okay, so that's how much work was done. Well, I can set 112.5 joules equals 1/2 mv squared. Okay, and we know that the m is 1.2, and now we're going to solve for v. So 112.5 times 2 equals, divided by 1.2 equals, now take the square root, and I have the velocity equals 13.7 meters per second. Two significant digits, so it's 14 meters per second. That's cool. That is awesome. To know something about the spring and then be able to tell me how fast it's going to push something away, like a Nerf gun. This would describe a Nerf gun. If I could tell you how much that the Nerf arrow weighs and what the constant of the spring inside the Nerf gun is, then you could tell me how fast that Nerf gun was going to fly. That's awesome.